Hi, everybody. This is my daughter. What's your name?
Millie.
Millie. And I brought Millie to teach how easy it is to do ionic naming for ionic compounds. All right. So we're going to take some ionic compounds and we're going to make them real quick on the whiteboard. Millie, you ready to make some of these?
Yep.
Okay.
Yeah.
We got to turn our camera here.
I'm ready.
If you guys look at the board, we're going to combine a couple of different things. We're going to take like magnesium oxide, magnesium, and then oxygen. Okay. You see that, Millie?
Yep.
Yep. Okay. Magnesium. This is always magnesium. Okay. So this first thing, which again we call the cation.
Oh.
What sound does a cation make, Millie? Oh, that's the sound. Yeah, good job. This one's called the anion. Can you say anion?
Anion.
Good job. All right. The cation, whatever it is, again, it's always the metal. It always stays the same name. So this one's called magnesium normally. It's going to be called what, Millie? What was its name? Do you remember? If I call it magnesium, what should you call it?
Ma.
Say the whole thing.
Magnesia.
Magnesium.
Magnesium.
Okay. Yep. All right, let's take a look here. Millie, can you spell yet?
Yep.
What can you spell?
My name also spells M-I-L-L-I-E.
All right, let me ask you. Do you know how to spell anything else?
Yep.
What else can you spell?
O is for ostrich.
Pretty good, huh? All right. So magnesium. If I call it magnesium, that's the name of the cation. It's going to be called magnesium. Got it, Millie?
Yep.
All right. The anion is just going to be whatever the normal name was. We're going to drop a section and we're going to add "ide." Okay?
I'm ready to do this.
Wow, that's pretty enthusiastic. All right. So this is going to become ox and then "ide." Okay, we dropped the back part, right, Millie?
Yeah.
Okay. You say ox.
Ox.
And can you say "ide"?
Ide.
Let's put them together. Ox. Ide. All right. So this thing, which we had magnesium and oxygen ionically bonding, is now going to become magnesium oxide. Millie, can you say magnesium oxide?
Magnesium oxide.
Say it one more time.
Magnesium oxide.
Magnesium oxide. Can you say that?
Like magnesium oxide.
Good job. All right. That's pretty good, huh? Yep. All right, so we're going to erase this. We're going to do a different one. All right. Again.
Can I do it?
Well, you're going to have to pay attention. You think you can pay attention?
Yeah.
Okay. All right. We're going to turn it toward the board. Again, you just had the name of the cation, the first one. And then for the anion, you drop the end and you add IDE to the end. Ide. Okay?
Can I do it?
Well, I'm going to give you some examples. Okay? So the cation is always a metal. Millie, do you know any metals?
Nope.
Is aluminum a metal?
Nope.
Yes, it is. Aluminum is a metal. Okay? So aluminum will always be called aluminum when it's ionic bonding. Okay? However, things like chlorine, we have to drop the INE at the end, and we add IDE. So chlorine is going to become chloride. Can you say chloride?
Chloride.
All right, and bromine is going to become bromide. Can you say bromide?
Bromide.
And fluorine is going to become Say fluoride.
Fluoride.
Good job. All right. So that's ionic naming. All you do is you take the first name, the cation, and then you drop the end of the anion, and you add IDE. There's one other catch to this. Every once in a while, you're going to see a metal, and I'm going to give you, this is iron, Fe. Okay, can you say iron?
Iron.
Good.
Wait, E E's in my name.
It is in your name, Millie. Good job. Okay, this is going to be iron oxide. Okay, now when we do this, the cool thing about ionic bonding is that based on just the chemical formula, you can tell the name of it. You can also tell the charges of all of them.
That's Gray when he was little. And that's Gracie and Gray when they were little.
Those are our dogs.
Yep.
Cool. All right, so
that's when they were little.
I know. You're going to let Daddy teach real quick. Now, if you look at the naming of this stuff, okay, if you remember a couple videos back, we looked at the cross-multiply rule. 3 means that iron has normally, when it becomes an ion, when it oxidizes, it has a +3 charge. And then the oxygens, you look over here for this 2, carry it to that, it usually gets a -2 charge. Now, there are different ways that iron and some other elements can oxidize.
I know.
You gotta listen.
I know.
Okay, you gotta listen. You gotta listen. Iron can also have a +2 charge. So we want to know which iron we're talking about. In this case, since you figured out that it is a +3 charge, what we would call this one is we would call it, and we're talking about this right here, we would call it iron 3, okay, in Roman numerals, because it has that +3 charge. Iron 3, and then we still do that same thing that we've always done. Ox, drop the ending, add IDE, oxide, okay? Now, as you can tell, my daughter hasn't slept in her nap, and so if you have any questions, email me. I'm going to go make her take a nap. Do you want to say goodbye?
Bye.
Are you excited about your nap?
Yep.
Are you sure?
Yep.
Can you say iron 3 oxide?
Iron 3 oxide.
Good job. All right, so here's the point of all this stuff. And I've got my little pirate friend Millie to help me again. If I give you the symbol, what should you be able to give me, Millie?
What do you want to do? The charger and the name.
Yes, if I give you the chemical symbol for the compound, the ionic compound, you should be able to give me the charges of all the atoms and polyatomic ions, and you should be able to give me the name. If I give you the name, you should be able to give me the symbol. You should give me the charges. If I give you the charges, you should be able to predict what the chemical formula is going to be and what the name's going to be. So,
and you guys are going to help.
Help what?
Help us plant a new tree.
Help us plant a new tree?
Yep.
Is it going to be a chemistry?
Yep.
Sweet. Thanks, guys. We'll see you later.